Hey everyone, it's Friday.
Friday.
Let's mute
Hey
this too.
everyone, it's Friday.
There we go. Hey, welcome. Welcome. If you celebrate it, happy Good Friday. It's Good Friday. Apparently, people that schedule things for me don't realize that because I've got meetings all day long. But it'll still be a Good Friday regardless, and I get to spend time with you, which is great. So, welcome to Voice and Robotics. This is our Twitch stream that we do on Fridays where we cover sometimes voice things, sometimes robotics, sometimes we combine the two, sometimes we do ML and AI, sometimes we do data science, and that's what we're doing today is data science. So I'm going to talk to you about this blog post that went out on the 8th, so 2 days ago. But it's a public data lake for analysis of COVID-19 data. So hopefully you are all sheltering in place or at home and doing your best to lower the curve. But we're going to look at some of those curves today. So I thought we'd have fun with that. All Fridays are good, am I right? Yes, Trinity, all Fridays are good. So they're all Good Friday to me. I love it. And welcome, Trinity, by the way. Let's see. So COVID data. Let's lower the curve and let's look at the curves. Let's look at different curves. I know if the Lord of Sound, who is a regular on this stream here in the chat group, comes on later, then we can talk to him about his project he's doing with some of this data. But there's a lot of good data here. So let me paste this link. If you have some downtime you want to explore, there's so much good data. Let's see now. Let's walk through what you need. So you need an AWS account. So hopefully you have that. If you've done any skills, you probably do have that. You have a Lambda account. This assumption says permissions to create a CloudFormation stack. I haven't needed that yet, so you probably don't need this. If you have it, it's great. Permissions to create glue resources. I haven't needed that either. And in fact, what we do today won't require any of this. We're going to use some of the same data that it mentions, but it won't require any of this. The source of the data. Hey, Amazon Alexa. The source of the data is from several different places. One of them, Johns Hopkins. There's also a big, let's see if I can find it for you, in New York Times data. So from what I know, and we should be very careful with all this data, all of us should be, Allen Institute, we should be careful where we get our data from and who we trust and believe. But I think probably most of us think that these are reputable data sources. So Allen Institute is, in my opinion, a great one. Johns Hopkins would be a great one. New York Times, probably great too. So we're going to look at all these. So this dashboard here is, I think we've all seen quite a few COVID dashboards. This one is a public QuickSight dashboard. Now yesterday this one was not loading. Let's see if it's loading today. I think it got overwhelmed yesterday. But maybe we're early enough in the day where we can check it out. We'll check out this data. Yeah, this is further than I got yesterday. So this is worldwide stats, confirmed cases, deaths, recoveries, active cases, things like that. So really cool. A QuickSight, by the way, is a AWS product that you can use to take data and do these kind of visualizations and some data science. We're going to do it a little more different, something that you can do without costing yourself any money, and that is we'll use Jupyter Notebooks. So Jupyter Notebooks are these Python-based notebooks that we'll get into in just a second. So here's the data, and we'll do our own data, and we'll see if these numbers compare to what this dashboard has. Okay, so let's see if we can type GitHub here. One of the data sources in this is, it's one of these first ones, global coronavirus data. So a lot of it, there's a global one, but there's a lot of US-centric one. I want to keep this stream focused on the global data. So this global data is from WHO, CDC. So it's a collection and collected by Johns Hopkins. They have this is their lab, or it's from the School of Engineering. But let's go and look at their data. So they have daily reports, they have time series, they have a lookup table. This lookup table will show you country codes, and it will show you latitude and longitudes for countries. So if you do get raw data that doesn't have the country and the region, but you have latitude and longitude, you can use this table to do matching. But we're not even going to have to do that today. It's going to be pretty easy. I want to look at time series. I want to see how this thing has progressed over time. And so the goal of today is to show you how to get this data out of GitHub, how to explore it and analyze it with Python, and then the next step would be for you to use it in some way. So you could build your own dashboards. You could make an Alexa skill that says, let me mute her real quick. You ask her to tell you how many cases are in your country or a certain country, how many increases over yesterday, etc. So this here, we have confirmed global CSV. It's a big CSV file. And I believe, let's see what the last date is. 4/9. So we have 4/9. So I've pulled the latest data. in this notebook. So maybe we should walk through installing Jupyter real quickly in case you don't have it. The Jupyter notebook will let us just do Python commands. So if I open a new one real quick, let's just do a new notebook, and we'll do this. So I can just say, these are all Python commands, so I could say print hello world, and hit shift enter to execute it. 1 plus 2 times 4 is 9. So it's just basic Python interpreter, but the cool thing is it lets you go back and change things and go back and update. Let's see, we'll call this A, we'll make it a variable, and we'll do A, I think we can we do star 2? There we go. So that's an exponent, so we're squaring A. But it lets you go back and change cells. Now, if you've done Python in the command line, then that's a little harder to do. This is really easy. So Jupyter makes it super easy. To install Jupyter, I'll send the link to this. Install Jupyter Notebook. You can install it Mac, PC, Ubuntu, whatever you're on. So that's Jupyter. Now, there are also services like, I believe Google Colab is free. So if you want to use Google Colab, it's hosted notebooks in the cloud. So let's just make a new one. We'll call this, actually, should we do this in Collab? No, we'll do it local. You can do it in Collab. You can follow along with me. So you would make a new notebook. I'm just going to call this one COVID-19. I wonder if I need to hit new notebook first. Okay, and then we can do the same thing. So print hello world. A little bit slower than doing it locally. There we go. A equals 4 plus 2. We'll square that, so 6 squared, it should be 36. Hey, welcome, Ice Cream. Let's see, Ice Cream, since we've talked to you, there have been 168 hours. How many of those hours have you slept? If a normal person sleeps 8 hours a day, 56. I'm going to guess, because Ice Cream had a baby that's a week old now. So I'm going to guess, how about 7 times 4 hours for Ice Cream? Ice Cream's probably tired. Okay, so you can follow along if you want. Now there might be one. We're going to use a couple of libraries called Pandas. Pandas is really good for taking data and doing a lot with it. Well, let's see if it works in Collab. So import Pandas as PD. Oh, good, it works. Okay, so you can definitely follow along. And then we'll import matplotlib. This is important when we need to. Okay. Ice Cream says I'm going to say it's pretty close. 28 hours is pretty close. Okay. So here's what we'll do. We'll do this just so you can follow along at home. Now you can. I'm not just shilling. Let me make sure that you understand that there's an AWS version of these notebooks too. AWS SageMaker notebooks. But you have to log into your account. You have to create a notebook. It's pretty easy, and it's free to do with Collab if you want. And there's local ones too. So if you don't want to go through the process of installing local, then you can look at Collab or SageMaker. So we'll keep it in my local because it'll be easy, and it looks like it's a lot faster than Collab. So we're going to go through here. I will share this repo or this notebook with you at the end, so you can take it and do your own things. Because once you get this far, it's really easy to write an API where we can create an intent that is a country intent. And we can say, show me the values for France, for example, or show me how many hospital beds are left. Ice Cream says 7-year-old awake during the day, 7-day-old awake most of the night. At least a 7-year-old is, I would guess, is pretty helpful. Is able to maybe run and grab a bottle or help you out and be an extra set of hands, extra pair of hands in most cases. Okay, so the data I showed you earlier, the CSV, we're going to download that first. So all you have to do to download that is specify the URL, which we've done here. So I've got a URL. Then DF, you're going to see DF a lot when it comes to Pandas. DF is a data frame. So data frame, just think of it as an Excel table. And you can see a good example right here. Data frame just makes this all a nice table for you, but it lets you do a lot of actions on it. So we're going to read this data. I can say DF head to show me the first 5 rows. I can say DF tail if I wanted to. You can see the last 5. In the data, you're going to notice a few things. So some zeros. So this is good. So in the Falkland Islands, on January 22nd, there were 0 confirmed cases. By the way, we're looking at confirmed. Is this correct? Let me make sure. Confirmed global cases. I don't want to get too down about deaths and that. So we're looking at confirmed cases for now. But 0, and let's see at the end. So the Falkland Islands have had they had 5 They had 5 there. Okay. So we can see the tail. We can just also pick a random row. So we could say df, and I think we can just do it this way. Let's see, row 5. Maybe not. That's okay. Let's just look at df.head. We'll get the syntax for grabbing a row. Okay, so now we can filter by a country, a region, province, state. So you can see there's province, state is a header, it's a column header. Country, region is a column header. So for example, if we want to see France, I'm saying, we give it a variable name, so France all data frame. I'm going to say, give me the data frame at the location where data frame country region is France. So here, here's France. Here are the provinces that it has. And we can see all of those. If we only want to get France the country, then I would just look for France. And then there's this is null. So we're going to say, if there's an NAN in this province state, then that means it's the primary country. So this is the primary: Afghanistan, Albania, Algeria, etc. So we can get France that way. Now we can see France's data. So here's their data. Total cases. We can also do something fun where we get cases by latitude. So this latitude right here, this is between Dallas and New York City. Let's change it. So, hey Jenny, there's New York City right there. Hey Jenny Miro, welcome. Ice cream, tell me where you are again. Or let's see, I know Trinity is in Seattle. So we could do longitude. Let's do it by longitude. Let's add some new, let's see, we're going to insert cell above. Copy that there. And then we're going to insert one more cell above. And then we'll say get confirmed cases within longitude. I guess we can say by longitude. Longitude. The other cool thing is, if you're familiar with Markdown, you can change these cells to be Markdown cells or code cells. So longitude, we're going to go, we're going to spell it right first. Confirmed. There we go. Let's make sure we get those. Okay. And then longitude, we're going to copy this. We're going to say longitude. May you send me the materials reference? Of course, yes. So the first link you need is this. And hi, and welcome, by the way. There's that. And we're taking the time series data from this GitHub repo. I'm going to send you the repo, the main repo here. And then we've dug into COVID-19 data. This is new to 6 days ago, so I guess it's not new to me, or it is new to me. I didn't see this. I don't know what these situation reports are, but someone can check those out too if you want. But go to this COVID-19 data, go to time series, and then you can see different time series for different CSVs that you can download. All right, so longitude, we're going to go from Seattle to New York City. Or we can make it more global. No, let's do this. We'll do this for now. We'll get global in a second. Alexa, what is the longitude for Seattle, Washington?
The longitude for Seattle, Washington is 122.35088 degrees west.
Alexa, what is the longitude for New York City?
The longitude for New York is 73.9387 degrees west.
Okay. So Seattle to New York City, let's see. Whoops, I didn't like that, but we can fix this. All right, so LON, it should be LONG. Okay, it doesn't like that. Why doesn't it like that? Did it have a negative? It shouldn't have had a negative, right? Or west. Let's just see. Oh, greater than. So we want less than. Less than or equal to this. Greater than or equal to this. There we go. So, well, that's not right either. These are all, maybe you're getting an echo from your echo. You better mute it, Trinity. I'm going again. Alexa, what is the longitude of Seattle, Washington?
The longitude for Seattle, Washington is 122.35088 degrees west.
Alexa, what is the longitude for New York, New York?
The longitude for New York is 73.9387 degrees west.
Who's a cartographer here that can help me out? Why is this wrong? So we're doing everything less than 122 and everything greater than 73. Less than 122. I mean, we could rearrange these to make it a little easier to understand. So we're going to do that. Well, we definitely shouldn't be getting. So it's getting a negative 59, so it's less than 122, but it's definitely not less than 73. Is this an advertisement? Hi, Mariano. I don't. You might be seeing an advertisement when you first log in to the stream. I'm not advertising anything now. Let me know if I answered your question, though. All right, so here's what we're gonna do. We're not gonna solve longitude right now because I'm not a cartographer, and I really am not sure what I'm doing wrong. This seems like it should be right. We do have lat and lon, and it could be. So we can do this too. We can say df.dtypes and look and see if these are dtypes. We can look at the data type I thought of this data frame. Let's try it. Pandas data frame dtype. Trinity says, yes, you will get a Twitch ad when you first. Is W a negative 122? No, it shouldn't have been. Jupyter material. Yes, you want to know how to do Jupyter. Well, first of all, install Jupyter. You can install it on your own computer here. This would be a good place. If you want to use, Google has SageMaker, so we'll go AWS. Oh, good. I'll look at that link in a second, Trinity. AWS has SageMaker notebooks, and Google has Colab. So those are both Jupyter, hosted Jupyter in the cloud. So if you don't want to set it up locally, then you can do it in the cloud. All right, so let's look at Trinity's link here. It is negative 122. So, but Alexa didn't. Oh, she said west. So west indicates negative 122. And I'm sure NYC would be the same. So let's do. Did I already erase longitude? Did I already give up? There we go. We're going to copy this again. So we're going to say latitude. We're going to change this to longitude. I don't know why you would do this. I don't know why you would want to see it in this band, but maybe it's just another way to look at data. So this shows negative 122. So we're going to call. So we want everything less than or equal to negative 122, 3301. Alexa, what is New York City's longitude?
The longitude for New York is 73.9387 degrees west.
73.9387. Okay, let's try this. Seattle and NYC. I'm going to play with these a little bit here. This should be this way. Let's just say this is this way. Okay. That's more right. Except for United Kingdom. 5 rows. Nicaragua, Panama, Peru. Longitude. We're in this. Longitude measures. Longitude goes this way, so it measures east and west. I don't know. We got some data, but that's we're gonna say this is probably. Well, that would make sense because we're not getting state data; we're getting country data, and we're going all the way across this band. So yeah, I think we're right. Cayman Islands is part of UK. According to this data set, do you disagree? Trinity, let's find out. Wiki Cayman Islands. We need Jol work on here. He would know. Yeah, looks like it probably is a British territory. Wow, this stream you learn so many random things. Thanks to Trinity especially. Okay, so now we've got that. Let's also look at confirmed cases by specific date. So here for 49, these are the confirmed cases. 461 for US. They're in the lead. Yeah, Trinity says it seems correct, but it might be messing with us. I think it actually probably is. If you imagine a band around. Oh, the longitude's going this way, so a band around east to west. It might be right. It might cover those countries, but I actually think what we did too is we should probably be comparing a like a really big gap from north to south, but that's all right. I know what will happen as soon as the stream ends. It's gonna pop in. I'll figure it out. But that's how it goes on streams. Your brain works a different way. All right. Confirm cases by a specific date. So let's make sure this is right. So let's look at COVID-19 dashboard. I think this is not the one I wanted. There's a big one. But we'll try this one. I think this will show us, but if not, I know where another one is. Active cases by country. So I think we're just looking at U.S. right here. U.S. is 461,000. 419,000. So this one might be just a little bit behind this dashboard. So we definitely have up-to-date data, which is good, but let's try to find a little bit more COVID-19 dashboard. Who probably has a good one, right? Okay, here's the Johns Hopkins one. So it will use the same data. This is what I'm thinking of. So let's see, US 467, 473, so it's gone up. So we have yesterday's data, but it is closer. So we're getting good data. Now that we have data, we can plot it. So did I save the US? So France, we've got, let's look at, there's US. So let's look at the US plot. So what we can do on the total cases, we can look at the, I want to see where I defined US, because I don't think I defined it here and I need to do that for you. Well, let's look at France. So we have France. We know that their cases we're at 117 as of yesterday. So let's look at France. Okay, so here's France yesterday. And the reason I'm doing this 041000, let me show you what's happening there. So if we look right above it, insert cell above, look at France. So we want row 0. So this first 0 is a row, so we're going to have France. And then we want columns 4 through whatever. So we can actually just do this. Column 4, we would go 0, 1, 2, 3, 4. So 4 starts on January 22nd and goes, this colon without anything after it means go to the very end. You could also use 4 to 5. We could just see a 2 days worth, which we won't get any data. We'll finally see data on 4, 5, 6, 7, 8, 9. Let's look at 4 through 9. So we should see their little graph that goes to 3. All right. But we can also go all the way to the end, and we can specify some random number too. It's the same thing as doing a colon. Okay, so that's France. Let's grab the US. So I'm just going to copy this right here. Let's do trending data. Okay, let's create one here. Insert a cell above. Or to someone who's on the stream that's not from the US, France, or UK, we'll do your country. Anyone on the stream that we want to look at? For now, I'm going to put US, but I will change it as soon as I hear from you. So here's US, total cases. India, let's do it. Country region is India. I don't see startup Sanitana here. We're still going to go with India. Whoops. Okay, here's India. Anyone following along at home that wants me to paste code in the window, let me know. So India had 6,725 cases yesterday. Let's see. So let's look at trending data. So I'm going to keep this here. Let's just move this here. Move this right here. So here's India. We're going to look at trending data. So how's the data changing? And then we can look at just that first row from the 4th column on. And then periods will let you look over day. So the change over day. Let's see how the change over day has been. So 809 changes from the day before. So 809 new cases from the day before. We can plot that trending data. And let's see, it's right here. So here is so what we'd love to see as a society is that curve to flatten out. But you can see there's a lot of variation here. That could mean a couple of things. And this is an idiot talking too, by the way. But it could mean that we're not getting good data out of India. We're not getting. You can see the same thing with France. France has a lot of zigzag too. Or it could mean what they're trying is actually really working, and they really do have this much variance in cases between days. We know the U.S. is probably reporting pretty solidly. So let's see. Let's just redo. Let's get U.S. So we'll say this is U.S. I don't need to see the head of the data. Let's say US here. So that should give us US. All right, so there's that. That's a big drop, though. This drop here. And we can go back in time a little bit further, too. We can say, oh, here's the periods. That's the total. Let's look at US over period. Yeah. The same. Oh, periods is 1. Let's go back and look at like a 3-day trailing. That curve starts to smooth a little bit. But ideally, over time, that should be really leveling off. I think, was it Italy that's doing much better at it? South Korea is doing better. Let's see. This should be similar, a similar graph here. China is doing better. We know that. Let's look at China. So we're going to say China. Let's bring in China. It could be positional tuple is out of bounds. Let's do this. Just do period of 1. I think what's happening is, I wonder if China is not how it's listed. Let's find out. So the way we do that in a data frame is to see, let's just play around with some data down here. Let's find China. Find China. So let's make sure we have a data frame. There's all of our data. And now we're going to do a, let's see, we're going to do a string contains. I don't know that off the top of my head. We're going to say pandas data frame contains. String contains. Okay. I wonder what isIn does. Whether each element in a data frame is contained in values. I think it's string contains. Hi Mariano, is this your job? My job is to do training and education and write blog posts and videos for machine learning and AI and robotics. So data science isn't like a explicit part of that job, but it's an underlying part of the job. Especially if you think about building skills, data science would be really important if you look at your history of users and how they interact with your skill, how many users you get on a particular day, for example, or how many intents or utterances that they give you that don't map, and then you have errors. So you can look at the data and make a lot of good changes to your skill and try to increase your users, the retention, lower your latency, things like that. But data science is kind of a fundamental layer below robotics, AI, and machine learning. So every Friday, I do a video, a Twitch series or a Twitch stream on some part of that. Some days we do robotics. We play around with hardware. We make lights come on, or move robots, or look at autonomous vehicle simulators. Today, it's just data science. Hey, what's up, W. Giorgio? Data is everything. It really is. Data is gold. So I don't understand this S1. str contains S1. I think I have some. Let's see. Here we go. I've done this before. I did save some notes. We're going to use this note right here. All right, let's find China. So here was the note I saved. We're going to call this China equals country region where that is China. And we're going to print China. So there is no China. Oh, because I spelled it wrong. Still nothing. All right, so there's that. I mean, China has so many provinces. I guess we'll do Beijing. Or we could do... Is Wuhan listed here? It's not. Okay, so here's what the problem was. So let's just do this. Our string contains China, and let's do the same thing. B-E-I-G. Actually, it's all we have to do. Here, hold on, we're making this too complex. We're going to say where province, state, or we could combine all the China provinces. Data science is fundamental, not the way people talk about it. Not as it's understood and talked about. Yeah, so I think I know what you're saying. So data science is very fundamental. The danger or the problem with data science or data is that you can make these numbers say anything you want. So we could talk about how well things are going just by showing different reports. So you have to be real careful, like real responsible with data and with data sources, things like that. I think that's what you're saying, but let me know if you're not. The string contains Beijing. Cannot mask. I think we can just do it this way. Hold on. Let's get all of China. We did that up here with France. Okay. And then we can sum up, because we do want to see all of China. So let's grab it right here. Wuhan is in the okay. Is that Hubei? Well, we'll get them all now, but that's good to know. I didn't know that. Thanks, Jenny Miro. All right, so here's all of China. Maybe, but no, it's not. It's not grabbing everyone. Oh, it's the head. I want to see all of China. Can we see it all? Yeah. So Hubei right here. So they have 67. Oh wow. They jumped up on 122, which is the first day we started tracking. I think they were infected in December, but they were already at 422. They started hitting some exponential growth in between. Well, yeah, we don't see February here. This is interesting too, that their cases, they've leveled off. Hopefully those are real numbers, but that's encouraging. So we have China. Let's just try to plot China. We can do China.plot. So there is, what are we looking at? Oh, this is by day. This is not exactly what we want. Let's do this. We could just change this to China. Yeah. Big hit, and then this is a period difference. What if we can just do this? There we go. There's the curve you're looking for. And we can see US is still going up. So let's do one more thing and try to figure out how to combine. We want to compare graphs. So it's something I don't know how to do yet. So we'll try to do two plots next to each other or overlaid. So we'll say pandas multiple plots. I think we can do pandas or matplotlib. You can plot multiple subplots of multiple panda data using. Okay. So figure and axis using the x keyword. Okay, we already have that. Let's do this. Just copy this. Let's give ourselves some space. Okay. We're going to say plot multiple countries. And we'll make this a markdown cell. And here we go. So we'll say fig axis equals plot subplots. Number of rows equals 2. Number of columns equals 2. Then df1. So df is a data frame. So we'll say China is a data frame. Dot plot ax equals axis 0, 0. And US is a data frame. Instead of df2, we'll say that x equal axes 0, 1. That's not quite it. But we're getting at least plotting two things at the same time, which is good. There's a lot of different answers. Figure 1, subplot. That's kind of what we ended up with. We don't really want that. Here's a matplotlib of cat frequencies. Maybe we need to type in overlay. And we're going to say matplotlib. Matplotlib overlay multiple plots. I know it said scatter plots, but we can still do this probably. So let's try it. We might need this x. Linear space 0, 5. What is this? 0, 5, and 100. I'm not sure what that is. Let's just try scatter plots. So plot.scatter x, y1. Ooh, I don't know what that is. X is a value, X is some random numbers, so we're going to say this is going to be China. Y1 is the Y values. Let's try this. X equals, let's just say there are 40, what were there, probably 90 days of data? I don't know if that's going to work. X China, and then X US. NumPy India array. So it's when I use NumPy. That's not it either. Jupyter Pandas. Alexa t-shirt. I want one. How can I get it in India? Oops, close that off. This t-shirt came to me from my good friend Jeff Blankenberg. So you should check out Jeff's Twitch stream sometime. Blankenberg. And then when you're on that, ask him where he bought this, because he bought them from somewhere, and he has it. He had it labeled with our Twitch stream, our Twitch handle. It was a really cool gift. Okay, maybe this will work. X's and Y's, series YAX, index AX. I have no idea how we're going to do this one, because we need Y values, which are the dates. Or sorry, the X values, which are the dates, and the Y values are the sum of the confirmed cases. Let's get rid of this one. I've got that fixed there. Okay. Plus we're doing it with bar graphs. Let's try. That'd be a cool one to see too. It might be too. No, I think it's possible. I was going to say it might be. It might not be possible inside Jupyter, but it should be. It should be possible. So here's someone that did plot X and then the sine of X. Okay, let's try this. So let's do plot China US and then plot. I think we don't have to say plot.show. Maybe we do. X and Y must have the same first dimension, 0 and 83. So US has a different shape. Let's see what this is. US looks like that. China looks like this. China has no rows. What happened? So there's one row. There's 5 rows. Oh, okay. All right, so let's just pick out, what was it, Ginny Mero? It's Hubei. Let's try this. I hope I'm saying that right. Country region is that. We want state province. And Ginny's doing some good work too up in the New York area. Province state. So feel free to let them know what you're doing. Province state. Okay, good. So we're going to call this Hubei. That. All right, so now we should be able to see that US head has the same shape, same number of rows. Good. Now it should, hopefully we'll plot PLT, plot US and Hubei. Oh, we're so close. Unhashable shape ND array. Let's import numpy. Oh, ND array. What is that saying? US.shape and Hubei.shape. Same shape. I don't understand what unhashable shape is. Let's look that up real quick. And is there any other data, like, so you've seen the data we have. What else would you want to see? I'm trying to just overlay 2 plots, but we can do something that's more beneficial. So, given this data, where you have latitude, longitude, and then the date, the cases by date, is there any other date or country you want to look at? In the meantime, I'm going to look up this unhashable shape ND array. I think that's what it was. The problem is passing a list of arrays to the mode function. It requires a single list of value or single numpy array. Okay. So I think what we want to do is kind of convert this. We're going to say US confirmed equals US from 0 and then 4 on. And then let's look at US confirmed. That's an invalid key. Okay, let's see. We can fix that. Pandas take an array slice. We just want to slice out or select certain columns. Oh, location. Let's try that. Location, row indexer, column indexer. Okay, let's try this. Row and then column from 4 on. Key error 0. Okay. Can I just do this? Nope. Province state. What if I do, what's 3 on look like? 2 on. Or maybe it's got to be an extra bracket in there. Yeah, let's look at that extra bracket. Oops. So 0, 2 on. Just doesn't like that. None of blah blah blah. Okay. So we'll say pandas remove columns. I'm working with a friend, Jenny Merrill's working with a friend who's an ER doc, and they're using AI and ML to streamline processes. There's a lot of good, there's a really good, let's see if I could find, I think I took this note too. So Stanford in like the 3rd of April, had an event where it was a virtual conference. But this particular talk right here, I'll paste this here. They're using AI and ML to look through papers. So there's some research done by one team. I'm going to mute this. And late in the video, they do a lot. This whole video is really good. But late in the video, they talk about some potential machine learning machine learning they've done to find potential protein blockers and inhibitors that would affect that spike, that coronavirus spike. So they mentioned some really cool things. They did some clinical trials. I don't know where that video is. This was a 5-hour video, but I know the guy's face if I can find it. But he talks about a phrase, and I don't remember the phrase he used, but in this data set from AWS, one of the data sets, there's hospital beds, so available hospital beds, but one of the data sets are the papers that have been written, and there are tens of thousands of papers that have been written, research papers, like the one I was trying to find. And so one of the challenges for doctors and researchers and scientists is, how do we know out of all these tens of thousands, there's got to be some good work done? How do we look and see what good work's been done that we can either add on to or use in our work? So there's a good little example here of how to load all of those papers into a database and then just do SQL queries. So you can do select journal, you can use SQL, what are they called? Conditionals. So you can use conditionals to find, what journals mention a certain protein or a certain study or research. So that's one cool way that people are using just this data. But then there are other people that are on top of that. Lord of Sound is one of them that is doing looking through all the papers and pulling out keywords and key phrases and then making like word clouds to say, oh wow, these people are talking about this certain inhibitor or this certain protein or this IL-6. But I think it's a really cool way to use this data for research. I'm just not, I don't understand most of these papers for sure, but I think people that do understand them would really love this part. So if you know someone that's doing research, let them know about this blog post. Okay, so we were trying to, I'm going to close that. We were trying to figure out how to remove columns. I'm going to try this real quick. Data frame drop. Let's see if we get a good example. So drop A, B, and C, axis 1. Okay, this might work. So I'm gonna copy this so we'll remember it. So US confirmed, I'm gonna say US confirmed. We're gonna drop province. Let's just try a couple. Province, state, and country, region. Let's look and see what that looks like. US confirmed. Good, so we're getting lat long. Now we just get rid of lat long. Basically, I'm just trying to get rid of all I just want the numbers, because I think the other things in there are going to throw our graphing off. There we go. That's US confirmed. Let's do the same thing for Hubei. Confirmed. Okay. One extra equal sign. There we go. And now we should be able to see the same shape. So Hubei shape, we're going to say print this, print US shape. They're the same. Anoop. Who's Anoop? Is Anoop on here? Did we miss Anoop? Have you joined this wonderful session? So we have the same shape. Now let's see if we can plot those again. So we want to, I think we just can try this just like this again. We're going to say plot US and Hubei. Oh, thought we might get lucky. Same problem though, unhashable type numpy ND array. So let's go pandas, unhashable type. Let's see if we can solve this one. And p concatenate. Let's just make sure these plot too. So let's go here and just make sure that that's interesting. We're not getting the same pretty plot that we got before. Oh, we need to do on. Forgot we renamed them. Did someone catch that? Urban Blaster. Very interesting session. I'm not much of a data scientist, but I've played with SageMaker. Obviously, I'm not either. Like, I'm sure in fact, I know there are really good classes you can take online. University of Michigan has one that I looked at a little bit yesterday on Coursera. So 263 and 79. So I think it'd be really good to get good at this, and this is just a good way to try it. I think we can turn the legend off. So let's see. Pandas, turn legend off. Turn legend off. Legend equals false. All right, let's try that. So these are their cases, reported, confirmed cases. These 250, this X is just the column number, so we could probably rename that. Let's try it real quick. Actually, no, it's okay. It's days since reporting, so that's fine. So we've got that. Let's see what US looks like just to make sure that works too. US confirmed. Okay, how do we overlay these? We can try it again. So plot US confirmed and Hubei confirmed. Well, it's not an error. Plot. Definitely don't know what that is. Okay, let's look around a little bit more. Let's try to do something different. What else can we do with this data? Anyone have any ideas? Let's see what this dashboard does. I don't want to mess with deaths or recovered. I'm glad people are recovering for sure. If we look at, let's look at India. Can we zoom in? So it's just doing India on the whole. Cumulative confirmed cases. They're still trending upwards. There was a theory early on about how the cases were only seeming to affect the certain latitude range, this band right here, but really there's a strong correlation between population here too. And then now that other cases are becoming more apparent, then that kind of breaks that theory. This website link right here is this one. I know South Korea has really done a relatively good job of getting their curve back down, or the curve leveled out. There's the Wuhan. So all right, so what else can we do? Let's see, total deaths, total confirmed. This is by country. Let's see if we can figure out what's our main data. Is it just called DF? DF has all the data. Can we figure out who had the biggest drop yesterday? The biggest percentage drop? So let's get percentage drop first. So US is here. Head, and then how do we trail? We say period. Period is right. Okay. So India had an 800 increase yesterday, 605. So if we want to see, let's see. 1D, 2D, two D, 1D. Let's see what they look like if you subtract. Oh, we can't start. Let's do that. Can't start a variable with a number. Let's see. We need to add a little bit of break. 2-day trailing, 1-day trailing, difference. Let's see. You have a portal link. How does this portal work? Let me see here. I'm back on track, right? Let's see. Let me see this link before we pop it up. I don't know. From what it looks like a maybe a data archive, data portal. How does it work? So it looks like it's all HTML and CSS. It's probably just a lot of there's a lot of, if you're wanting to build your own dashboard, maybe that's what you're wanting to do, then there are a lot of free dashboard widgets. So let me show you a few because they're really fun. Once you get this data, I guess the whole point of this too, by the way, today was to show you how to get this data out, but then you can make these API calls. So you can basically say, show, you can set up functions in Python to get this data out and then respond back with your, as answers in your skill. But you can also use it for data dashboards. So look at D3JS. You missed MATLAB. Oh man, I haven't done MATLAB in forever, but MATLAB is really good. And welcome, Simply Apples. Have you tried Pandas, Apples? So we could take this data and do some really cool stuff. There's some good... this is good for making, you can include this in your HTML file, so you can make really nice dashboards similar to what you had sent. Pandas Apples is the data, it's the library we're using to do all this data. So we can load in a CSV into Pandas and it gives us a nice tabular view, and we can filter and sort and all of that. There's also Seaborn. I guess Folium is the mapping one, but so we could use, I tried using this yesterday, but Seaborn is a really good visualization library, but also does, yeah, look at these heat maps. So this is what I was trying to get to, just a heat map where the color, the darker, the brighter the color, the more red, I guess, is the days that we're not really tailing, but we might be increasing. Blue is that the confirmed cases are decreasing. So that'd be fun too. If someone wants to try that, I'll paste this here. Let me give you Seaborn first. Seaborn does really good scatter plots. So Seaborn is kind of a, I call it New Kid on the Block, but it's 2012. And the classic one is Matplotlib. This is what just about everyone used or uses to do this kind of visualization in Python. and it's been around. Let's see if they have a copyright. 2002. So, not that it's old, it's still very much used, and it looks like maybe, let's see when this latest version was out. It's probably still being developed. Yeah, it looks like it. Okay, we're about out of time. I hope that kind of shows you what you can do. So we started off with data from AWS, so we're getting all this data. It's not from AWS. AWS is aggregating it and providing it. So you can get this data from AWS, then you can have all sorts of good learning experiences by playing with that data, building APIs, using it for your Alexa skills or your dashboards. Any questions before we go? Great, thank you, and thanks Apples for joining. Thank you, everyone else. There's a lot of new people in here, so it's good. I always love seeing new people and getting some new content ideas. So if you have content ideas for this show, something you want to see more of, or something we want to go deeper on, be sure and let us know. You can tweet us at Alexa99 or Alexa Devs on Twitter, or myself, JB Nunn, on Twitter. Trendy, thanks for joining. Gene Mero, thanks again. W. Giorgio, everyone else, Urban Blaster. Great seeing you as always. Have a good weekend. Hope it's nice where you are, and I hope you get outside. That's important. Get outside and then say hi to your fam. Congrats again, Ice Cream Codes. See ya. Bye.